What is a DC motor and how does it works? First of all, let's understand how does a simple electric circuit works. We have connected a bulb to a DC battery wire switch. When we turn on this switch, the electricity flows from the positive end of the battery through the switch and bulb and flows back to the negative end of the battery. The current direction is from right side to the left hand side. This completes the path of the electricity and the bulb turns on. Now let's reverse the polarity of the DC battery by flipping the battery terminals and turn on the switch. This time electricity flows from the left to the right hand side through the bulb and bulb turns on normally. But not all electrical devices behave same as bulb as we change the polarity of the electric current being supplied to them. For example, an electromagnet. Before going to the electromagnet, we will see how does a permanent magnet works. Now let's see a permanent magnet. It has two poles, north and south poles. If we bring the same poles of the magnets close to each other, they will repel each other. And if we bring closer the opposite poles, then both poles will attract each other. Now let's make an electromagnet. We will take a metal rod and wrap some turns of wire on this rod and supply DC power to it. As the current flows through this circuit, it produces the magnetic field around this metal rod. And this metal rod will start to act as a magnet with two poles, north and south pole. Now, as we reverse the polarity of the battery, the direction of the current flows is now opposite. And it changes the polarity of this electromagnet. Now let's hang this metal rod on the simple needle in such a way that it could rotate on it. Now, if we wrap insulated copper wire on it and connect the ends of the wire to the battery wire switch, as we turn on this switch, the current flows through the circuit. It creates an electric field around this metal rod, and this metal rod acts as a magnet with two poles, north pole and south pole, and this magnet will attract objects same as permanent magnet does. Now, if we bring permanent magnet with same poles near to this electromagnet, as the same poles repel each other, the electromagnet rotates and opposite poles align with each other. Now, as we change the polarity of the battery and turn on the switch, this time the circuit flows in the other direction, and this will change the polarity of the electromagnet. Now the same poles align with each other, and these poles will repel each other, and again this electromagnet rotates and opposite poles align with each other. We can use this property of the electromagnet to make a DC motor. Now let's make a DC motor step by step. First of all, we will replace these permanent magnet with the curved magnets, and we will put a loop of wire inside these curved magnets. Now, if we apply the DC power to this loop, it creates magnetic field around this loop, and it acts as magnet and start to rotate and align the opposite magnet poles of the wire loop and the permanent magnet with each other. Now, to rotate this wire again, we have to reverse the polarity of the DC power supply. It will reverse the polarity of the electromagnetic field around this wire loop, and this wire loop again rotate to align the opposite poles of the electromagnetic field of the wire loop and the permanent magnet with each other. We can rotate this wire loop or armature by reversing the polarity of the DC power being supplied to the wire loop. But this is quite a work to do. To avoid this, we will attach two copper half rings at each end of the wire loop. This is called as commutator. We will apply the DC power to this commutator through the carbon brushes. These carbon brushes are spring-loaded against the edges of the commutator to make sure a stable contact between carbon brush and the commutator. As we apply the DC power to this commutator ring, the current flows from right to left hand side through this wire loop. This creates electromagnetic field around this wire loop and creates poles around this wire. And these poles aligns with opposite poles of the curved permanent magnet. And wire loop or armature rotates. As the armature rotates, the commutator also rotates. And this time around, the brushes will switch contacts with the other ends of the commutator ring. Remember, we have two brushes, so this is happening on the both sides at the same time. Before switching, the current flows in this direction, and after switching the brushes, the current flows in the other direction. This means the electromagnet switches the polarity, and this armature will keep on rotating. Now this rotation movement is a bit jerky with a while loop, so we can insert another while loop in this setup to smooth this rotation movement. Now we have 4 pieces in the commutator. We can apply the DC power to the commutator. The current flows through the armature, and as it rotates, the brushes slip onto the other while loop. And this while loop gets supplied with the electric current, and it gets energized, and again armature rotates. And this process continues, and armature continues to rotate. Now this is a very weak motor. To increase its power and speed, we have to modify it. We will remove these wire loops and insert a proper armature in it. This armature has 2 laminated wire coils wrapped with a multiple number of turns around this iron core. The iron core consists of laminated sheets. These laminated sheets are stacked together to create stronger magnetic field by reducing eddy currents. As you can see that if we apply the DC power to the carbon brushes, the first coil of wire gets energized and it creates a strong magnetic field around it. And the north and south poles of the armature aligns with the permanent curved magnets. At that moment, the brushes slips onto the other coil of wire through the commutator. And this time, the other coil gets energized and it creates a magnetic field around it. And armature rotates to align the opposite poles of the armature and the permanent magnet. And this cycle repeats itself as long as the electrical power is supplied to the commutator brushes, and the motor keeps on rotating. Now to complete the DC motor, we will remove the DC battery wires and plug in a back cover. This back cover will secure and hold the carbon brushes. Next, insert the whole setup inside the outer casing to keep armature and curved magnets in place. And that's how a DC motor works. And that's how the DC motor works, by continuously reversing the current with the commutator. The armature keeps rotating, creating motion. Thanks for watching. If you found this helpful, don't forget to like and subscribe for more simple science explanations.